All right, well, good afternoon into our coronavirus conference. Um, so we've kind of moved to this format where we're going to basically have an interactive discussion with our guest, Douglas Held, who's a senior principal security consultant for NetSuite. Briefly, my experience with NetSuite is that when I was at Stanford, I was interacting with with Evan Goldberg, who helped co-create NetSuite. And what he had communicated to me back then was NetSuite is fundamentally a business information source online. So as I understood it back then, they were developing accounting infrastructure, and it wasn't necessarily formal accounting for financial reporting. It was more management accounting, business operational stuff where they had a dashboard online, and they hosted on their servers the data from small and medium enterprises. And then they had you could get on a web interface and get a dashboard of all of your business information. I'm sure it's evolved since then, and it's now part of Oracle. I knew Larry Ellison at the time was helping back the NetSuite enterprise that was developing. So this is what led me to actually try to find Douglas, and because I knew NetSuite would be one of the companies that would have a lot of familiarity with this issue. Now, to be clear, before we introduce Douglas formally, just to remind the students, we are under Chatham House rule, and Douglas does not have, I've not asked him to specify anything about NetSuite specifically. So this isn't about NetSuite. It's more about his experience with just the issues of online hosting of data. So with that kind of long preamble, I want to introduce Douglas and thank him for coming, and ask him to give us more color about his background, if you don't mind.
Sure. Yeah, I'm delighted to be here. My name Douglas Held, and they call me the security consultant within NetSuite. I have a background of over a dozen years in software development and software consulting. And sometime around 2007, I switched in my career to entirely software security work. And my first experience was at a company called Fortify, and through evolution of the company, I saw many of my senior peers leave the company and go to a company called NetSuite. And so I was ready for a change and blindly followed them, just assuming if all of these intelligent people are going to this place to do this work, there has got to be something of value for me. So what happened when I joined in 2015 is they created a new role for me called security consulting. And there was already an operational security team and an application security team. And they wanted me to be inserted into the organization in a new way. I think with the expectation that I would look with an outsider's perspective to be able to cut across organizational boundaries and make recommendations maybe that an insider wouldn't think of. So that being said, my job is to guide and evangelize security, and my customer is typically developers and product managers who are improving and adding new features to the NetSuite service. So I think at the time NetSuite was created, what makes NetSuite different from other accounting software peers at the time is obviously that all of so the old way of doing software is a company would create a software capability that would run on a computer. They would test it with test data in-house, and when they felt it was suitably tested and ready to be used, they released the software. It was released on CD-ROMs or floppy disks before that, and later software downloads. But the operational practice was the customer, the accounting customer who bought the accounting software, would have their own IT staff and their own computers that would run the software. So if something went wrong, they would go to that organization's support department and provide some sort of evidence of a symptom of something going wrong. And the software vendor would then have to figure out what might be the cause of the problem and make a new patch to the software for the customer to install. This should sound familiar. Everybody has computers with software running on them. But the cloud concept took away this whole task of the customer to operate the service on their own. So NetSuite, or the cloud vendor, we'll say, owns the computers, figures out when to buy new computers and upgrade them, manages the network connections to make the software available to the customer, monitors what's happening in the service, finds whether there are any defects, and has the opportunity to proactively fix defects maybe before a customer reports them. But most importantly, but this is basically just employees working for company A are now working for company B, solving the same problems. The huge difference, and what makes a cloud business is what's the word? The fostering of the data. So whereas in a traditional software environment, the data is kept on company equipment and company premises, in a cloud model, the customer has to completely trust the cloud vendor that they're handling the data appropriately. Some of the hot areas are tenancy separation, whereas in the old model, there's only one customer's data running, saved on that disk spinning in the computer. But in a cloud model, there are different customers served in the same service. And there's a couple of different ways architecturally that the service can choose to separate that data from one another. But regardless of which architectural choice they choose, it comes down to there are a possibility of making a blunder so that one customer, when trying to use the service, accidentally sees another customer's data. So this would be considered a breach of tenancy separation. So because the root cause of a problem like that is human error, the best that you can do is assume that errors will happen and have a robust program for testing software, having different roles responsible for security critical handover processes, like say a QA sign-off. When a defect is fixed or a new feature is implemented, it's critically important that the person who did the work is a totally different role from the person who approves the work and says, yes, it meets the stated criteria for what we wanted to fix, and it meets all of our business criteria for being good enough. Part of that QA sign-off should also be a security review to ensure that an error at a different level of abstraction didn't introduce a new risk to the customer. And so when a cloud customer submits the control to a cloud vendor, they may or may not be experts in software engineering and software security. And so they need somehow to trust this vendor. And there are a couple. So hopefully as accountants, some of this stuff should be resonating, like, two different roles executing a security critical control flow, like an expense report approval process. But how to advertise this trust? Party A is saying to party B, this service is safe enough for you to use. It's worth the money you're going to pay for it. But how does party B evaluate that statement? Because of course you could look at every vendor's website and they will all tell you that, for whatever reason, that this is the best service and it's very, very secure or completely secure. The reality is, since anything that's complex and built with human hands can have mistakes in it, all software actually has bugs. And what you want to know is not that there are never any, that there will never be any bugs in the software, but rather you can get some assurance from saying that a third party has evaluated this organization and has stipulated that The organization has meets a minimum bar of having teams ready to carry out security necessary tasks. Maybe that all of security in an organization rolls up in the hierarchy to one person ultimately responsible for security. These two things are objective measures that can tell you that an organization is ready to create and to serve a secure service. There are additional measurements. Within the security organization, does a vendor have a team dedicated to incident response? Incident response is typically used if there's an outside report of somebody being attacked by using the software, or attackers using the software as a vector to harm other parties, or if data that shouldn't be shared was spilled into an environment where it wasn't allowed. This is typical conditions to meet a security incident. And I think a sufficiently mature organization should have a dedicated team who's sitting around, like the fire brigade, sitting around ready to respond to those. Looking backward in time, so these are looking at how something is served. When the software is built, I think recent history has uncovered that if software isn't built with knowledge of security defects in mind, that security defects will result. And this is part of a bigger picture, that when an engineering student has their first day of school, it's very likely that the professor will be explaining to them situations where something that you could contribute a design to that gets physically built in the world, like a bridge, could have a flaw that harms people. So it might be typical to watch a video of people who designed a bridge in an area where they compensated for some expected winds, but not all of the expected winds. And shortly after the bridge was built, some winds blew and the bridge shook and shook until it fell apart. This is a very sobering moment for someone who's going to embark on a path of engineering. And in days gone by, maybe 20 years ago, the first day of a software developer's university studies started very differently. Typically, they would be shown how to write a program that prints "Hello World," a maximally simple computer program to show you how programming is done, and then perhaps would get a very flowery lecture about how anything you can imagine you can build. And this is a very different mindset to start with. And in more recent days, I would say starting with about 2005 to 2007, the concept that if you don't explicitly build security into software, that you must expect that there will be security defects that allow a variety of problems later in time. And further research then showed, on top of that, that the price of addressing a security problem early on, before the software is shipped, before you have to send out patches, to design the software, maybe even to look at the high-level design before code is written, that you can, as a software vendor, you can experience 100 times cost benefit. The cost of saying, oh, whoops, we better have 2 people sign off at that step. Or, oh, whoops, if we're receiving that data into the program, we should double check that the data can't contain some control characters that could subvert the operation of an underlying part of the software. These are easy things to catch very early on when you know what you're looking for. And they're very difficult to retrofit into older software. So if I can come back to my point from a few moments ago, what are the attributes of a company that's going to serve a service to you that's secure? It would be, you could make a short list. It would be a company that has a capability of designing security into their software, a capability, a hygiene practice of cleanly defined roles and security critical handoff processes that lead step by step from source code work to a finished product. Operational readiness to respond to future expected problems or known or unknown unknowns, and also an organization of security that's clearly defined, uh, definitely with with one person at the wheel with the final say for signing off on, say, accepting risk or mitigating risks. And uh, so if you're going to buy a service from a cloud vendor, if you're a very heavy hitting investor, you might have the luxury of being able to visit, the factory floor where developers are creating the software and to inspect their processes directly and satisfy yourself that everything is being done. But nobody in the real world has that capability. How could you ever do such an invasive test of a company that you would have that level of confidence? And so instead, the easy way to address this is to pick off of the shelf third-party certifications. And I'm sure you see the same thing in the accounting world. There is a certification out there called ISO 27001, which stipulates probably 2/3 of the qualities that I discussed to you in the prior couple of minutes about states that this organization has a clear hierarchy and organization of security with a certain number of necessary components that are ready to go, and carries out periodic reviews of people with highly privileged access into systems, such as people who can reboot the servers when there's a problem. That's a very highly privileged operation, and there are many such operations involved in running lots of computers. So ISO 27001 would be one way of having a high degree of comfort that a vendor can produce a result in a secure way. And there are other certifications as well. There's a certification SOC, we call them SOC 1 and SOC 2. There's also a SOC 3, but I think SOC 2 is kind of considered the gold standard. This is a standard for security practices met in operation of a data center. There are also certifications or external audits that cover design of the software. And this is a slightly newer part of the industry. And the best one that I could think of when preparing for our conversation is a program, I think that was jointly sponsored by some software security academics and also the United States government, a program launched called Building Security In, the BSI program, which later grew or matured into something that's called the Building Security In Maturity model. So if you take a look at bsim.org, you can find a document with a lot of detail about good security hygiene practices that are actually observed by our most sophisticated software development entities today. So those entities are probably banks and the financial industry, where they've invested effort in doing security the best way for quite some years. So this is one way of evaluating an organization that writes software. Another way to get an easy win is any software that processes credit card transactions beyond a certain small threshold typically needs to meet a payment card industry data security standard, which everybody calls PCI DSS or sometimes just PCI. And this is also an invasive audit involving interviews of key staff to find out what practices are in place, as well as penetrative testing of the software. You can either call it penetration testing or dynamic testing, which means that you're basically that you're not just helping the developer with the source code, but that you're looking at a running system and with knowledge of security and typical ways that applications fail, actually probe the software with attacks to see how it responds. So I think I've come out with quite a pile of words here. Um, I guess what I'm summarizing is a concept called security by compliance, which is a way that a well-organized vendor of software and provision of a service based on software can demonstrate to an outside party what kind of security behavior or security posture they take as an organization.
So yeah, so thank you for that. That's actually really interesting. What I found really interesting, and it reminded me of a discussion I had with Evan many years ago, where it sounds really efficient in some ways to move to a single source vendor who can provide all this infrastructure security around the software. But to me, one of the concerns was the access points. So in other words, storage, redundancy of system, things, disruption with access. So if the internet goes down, if power goes out, if all these other issues come up. I was wondering if you could speak a little bit to that, because if I host on my servers, then they're local to me and I can have access to all that data. And so I was wondering whether you've had any experience with that kind of issue.
Yeah, I think I can address this in a general way. So the kind of things, I think in the software world, maybe we use access in a different way. But the ability of the customer to access the data over the internet is one area that's important. I think that this can be handled with some redundancy on the service side, usually by splitting the elements of their service between physical regions. One region could have a flood, the other region might still be safe. Also splitting the capability within one region between two different availability zones. And so this would be maybe two facilities across the street from each other, with completely separate power supplies and fire suppression systems, etc. A third type of redundancy it might be that within one point where a computer could be plugged in within one data center, there could be not one ISP providing internet access, but often two ISPs or more. Typically in a data center, there might be 7 vendors providing the internet backbone service into that building. And so a service might have the luxury of choosing 2 of those, paying for the service entitlement of 2 of them, to have 2 separate pathways to the internet available at any time. Very nitty-gritty details that I don't get into in my job responsibilities would be things like redundancy in power supplies, backup power supplies. There's typically diesel generators on the roof and some batteries to handle a short-term period of the diesel engines starting up. It's nice to see that those are redundant. Part of a good physical security plan also checks that the diesel tanks are actually full of fuel. I worked in my younger days. I worked in a hotel in Jackson Hole, a ski area, one of the smaller ski areas in the region. There was a big power failure, and there were people up on the ski lifts. The diesel generator kicked in, and it was out of fuel. It had very small amount. I won't say it had 1 gallon or 2 gallons, but it only ran for a few minutes before the emergency backup power source ran out. It was a huge embarrassment for the company. So of course they had to manually rescue people down off of the ski lift. So redundancy in nearly everything. Any computer disk can crash, and computers have ways of splitting the data across different physical disks in such a way that you could pull one out of the running computer and put an empty disk in, and it intelligently it will spread the data across multiple disks in a way that loss of one complete disk doesn't actually lose any information, and it will automatically refill the data on that disk. So these are some elements of, I think, business. We usually term it disaster recovery in the computer world, and I think business continuity is perhaps, it's a term that's used hand in hand with the two, but I've had a suspicion that business continuity is actually an accounting concept and maybe doesn't have to do with the running of the equipment efficiently, but rather another aspect of the business that I'm not expert in. Alan, I would like to check back on whether I've addressed your question adequately. You mentioned different ways of accessing, and
yeah, I was just thinking in terms of the, if I were trying to contemplate whether I was going to do my own in-house or whether I was going to go offline and allow somebody else to host all of my business data, I immediately I'm like, well, what if I need access and I can't get access? And I was just thinking through the whole avenues by which I'm entrusting that there's redundancy, I'm trusting that there's proper storage, I'm trusting obviously the security that you discuss and that you work on with respect to the software itself and the hacking and all that, but I'm also entrusting that I have internet service, power, all of these things to gain access. Whereas, if you're even really small or you're kind of a startup, you could actually do it in QuickBooks or something like that. So just when it struck me that this particular business, and again, I don't want to focus on NetSuite specifically, but when I was thinking in terms of what it's providing, I was like, that's really clever. But it also comes with some issues with respect to in-house. And I actually think some of this relates maybe
sure
to
you're online to take advantage of the service. Is I think what you're saying.
Yeah, that's part of it. And it's also, it's a trust issue, right? So I'm also thinking maybe now as I'm moving ahead into, the blockchain, right? So we're going to start sharing access to data, and I'm going to host it probably in a cloud somewhere. So right away, then I'm kind of like, well, who's hosting it? Where is it hosted? What infrastructure do they have? Who's accessing it? All of this stuff just comes into my head.
Yeah, well, a blockchain is a very different concept that I'm by no means an expert in, but my understanding of, say, the Bitcoin blockchain is that there is no dedicated infrastructure. You're entrusting infrastructure to all of the disorganized parties who have a mutual interest in the system continuing to function. But I think when it comes to access and trust, something very worth talking about is trust of humans. People, highly privileged access is a necessary part of computer systems. And you might think about the risks that you take on when you run the system in-house yourself. You have to trust the highly privileged members of your staff who will have super user access to these systems, and also trust or hope or mitigate the risk that one of those key people could leave and take knowledge with them that hamstrings the rest of the organization. When you outsource to a vendor, you're likewise trusting that the vendor not only minimizes these points of human contact where a highly privileged individual could, say, log into your database and peek at the data. There may be certain acceptable use cases, such as looking for data corruption, want to make sure that the application didn't corrupt the data, versus inappropriate accesses of data that you don't want to see, such as somebody just curiously looking through customer data. I think you take on the risk of an insider doing the wrong thing with either one of these solutions. But I think there may be a principle by which the larger organization, meaning the cloud vendor, might have some additional ways to work around this risk by simply having a larger staff, additional people, and the typical mitigation to highly privileged access, when you can't just remove the access, is audit data. So there may be highly privileged access situations where everything the operator types is logged to another system as he types it in, so that if there was ever a suspicion that there was a bad actor on the inside, somebody can replay exactly what he did, in the hopes of not only finding out what the extent of the problem was, but also changing back whatever data might have been lost. I think I might or might not have mentioned data backups. Anytime data is sitting on a disk, there's a possibility for that data to become corrupted or lost. And there are backup schemes, typically taking a full backup every long time period and making incremental backups more often, and collecting these backups in a way that you can rebuild the data set to many different points in time if necessary, and also ensure that additional physical risks like a fire in the data center are also mitigated and cared for. So typically, I would say most cloud vendors probably don't even do this kind of thing on their own. They're probably taking part in third-party services provided by the data center vendor, who may have a service where they have a robot that plugs in backup tapes and puts them on a queue to be driven to another location on a truck. These parts of the business are pretty far removed from my day job, which is software designs. That I'm sort of, I may not be the most educated person in the world to address those. Alan?
Yeah, that's really interesting. I'm wondering if Marion or others have questions as well. So I don't want to give them the opportunity.
Yes, I do have a question. Thank you, Douglas, for your interesting presentation on cybersecurity and open source. So as as a personal user, for example, I recently came across like open source alternatives to Dropbox. So it's cloud storage, but more as an individual and not as a company. And I would just like to ask your opinion on open source software, perhaps in cloud storage and cybersecurity. Like,
Yeah,
yeah.
I think open source is a fascinating topic, full of potentially full of misunderstandings. So so I think if we're going to talk about open source software, we should first define what is commercial software. Commercial software is when staff members of a company author the source code and compile it to a program that they think runs well enough, and then sell the compiled version. As a general rule, even though it's theoretically possible to do so, as a general rule, you can't look at the compiled version and reverse it into the source code. And so in a commercial model, the source code is top secret. This is the secret intellectual property of that software vendor. And their general feeling is if an unauthorized party were able to steal that source code, that their entire business could be stolen. Somebody else could make a small change to the source code and serve their competing service that works the same way. This is a commercial model where, I guess in summary, the source code is secret. The open source model is different, and there are different ways of achieving open source. The typical way that people think of is interested people who want the software to be shared donate their skills for free into a public forum where the open source software sits and is available for anybody to inspect and compile and download and perhaps modify. Typically what they do is they will protect this source code, this public source code, with some kind of license protection. The main licenses are yeah, do I want to get into licenses? Some licenses say you can do whatever you want with this source. You can even package it up and start selling it. Others say if you do sell a compiled, something based on this software, you have to disclose that it's open source, and you have to yourself give away all of the source for free. And so this is, in the business world, this is termed a viral type of open source, which viral doesn't mean that it's bad. It just means that the principle copies itself to descendants, that it's impossible to take certain types of open source software and to form a commercial business by selling, maybe keeping certain parts secret, some extension or improvement to the software, and then using open source for the remainder. Whereas there are other types of open source that allow this mixing and matching of the capability to make money in business versus the capability for the end user to openly inspect the open source software. So there are quite a few different ways that an open source business can operate, but where it gets very interesting is the company that consumes the open source software must take on the risk of any mistakes or outright attack vectors that have been secretly inserted into this open source software. And here begins an interesting misconception that I think is sometime in the late, around 2000. I'm not sure if it was before or after 2000. There was a guy, unfortunately, whose name I've forgotten now. I'm thinking it's Adam or Alan, a chief early contributor to the Linux kernel. He wrote an essay called "The Cathedral and the Bazaar," where he posited that because open source software is open to inspection by anybody in the world, that it ought to be the most secure software in the world, because he called this the principle of 1,000 eyes. If thousands of people are able to evaluate this code and contribute improvements to it, you would expect it's probably as secure as it could be. But empirical evidence later on showed that this was by no means true, and that open source software was often hamstrung by a very limited capability of the team responsible for development to respond to reports of problems or security vulnerabilities in that code, and that it was often well-established commercial vendors like Microsoft, Microsoft for many years had a reputation of being an insecure vendor, a vendor who was pushing dinosaurs that were not fit for purpose. But the reality was that in recent days, maybe 2005 onward, Microsoft built an incredible capability to respond respond to software risks and to improve that software. And so the research later showed that the 1,000 eyes postulate didn't end up looking true, in that even though open source software is visible to many, many people, it didn't actually seem to result in people finding and fixing all of the security vulnerabilities that sat there in plain sight. So what's interesting about open source is the vendor that you learned about, Marion, who says they're running a service based on open source software, they may be using this term open source to make the service seem more friendly or more reliable, or maybe less capitalistic. Any of these claims or impressions could actually be true, but they also could be not true. The reality is that although the software that they're running might be open source, the service that they offer, the blood and the sweat and the tears that makes the service reliable, and the people who log into those servers ensure that the data is backed up reliably, etc. Nothing about the actions of this service that are carried out are really open source, because there isn't, open source is a concept that applies to the software source code and not to the business practices of the people who keep the service up and running. So
yes, now I see. So there must be, for example, an ISO standard linked to it to qualify more for cybersecurity in open source software plus business practices.
Yeah, well, I think if a company that relies on serving software and doing it well is using open source software, they must, I would say they must put the magnifying glass on the open source software to the same extent that they do to their own software. Otherwise, they may be turning a blind eye to the risk that's brought. Now, I can barely imagine any vendor who's not using open source software. I've never encountered any vendor where open source software is not allowed. And so I think it's fairly pervasive. We can find it everywhere. If you're using an Android phone, you know, the core of the operating system is based on Linux, and the application subsystem Dalvik is open sourced. If you are using an Apple computer, most of the operating system is available as open source. It's a variant of Unix called Darwin. And if you're using a Microsoft computer, this would be culturally the pinnacle of closed source software. But Microsoft makes no secret of the fact that that they, for many of the core functions of the software, they have used open source software from the University of California, Berkeley, which distributed its software explicitly saying you can do anything you want with this software, including bake it into your commercial product without necessarily having to disclaim this to your customers. And so I think the open source software is everywhere, and I would perhaps be sure that you understand what open source means before you would use a vendor's claim that they're better because of open source. Critically evaluate that rather than perhaps trust that it means that that there's an implicit expectation that the software is better quality, etc.
Yes, yeah, no, thank you. It was not really, yeah, my first opinion was, or the first, perhaps, yeah, opinion was that it was indeed more insecure, but but at the same time, I do really understand the way that everybody could look at the code and see that there was nothing encrypted to know that all the information will be taken out. But still, because it's open, you don't know what kind of resources are backed to it. If it's also you're not paying for the product, then you don't know exactly what kind of human or protecting on addition to the product. But of course, all companies, yeah, I understand, use open source products anyway. They just don't.
Yeah. So Marion, I think your your initial impression that the open source product may be less secure could or could not be true.
Mm.
I am I'm equally well. I'm not sure whether you were expressing ambivalence, but I'm definitely ambivalent about whether it's open source or closed source. And what's more interesting to note is, can you glean any information about the software hygiene practices of whoever contributed to this code? So there are some open source projects that are highly respected, such as Linux, and there are, of course, many others. I can't think of an example, and maybe it wouldn't be nice for me to name one, but there are many examples of open source software that are not being maintained. So maybe I could help you answer the question, how can a person who's not a software developer assess whether an open source technology might be safe or unsafe? And I think you might look at two metrics. Number one, how recently was the software changed? I think if you haven't seen a commit to that software tree since 2002, that there's a high likelihood that there are vulnerabilities in there that nobody bothered to fix. If on the other hand, you look at a project, say like Kubernetes, this is an open source framework for which there's many commits. It's very active and fast growing technology. This is, to me, risk at the other end of the spectrum, that the software is changing so rapidly that it might be lacking some stability, in which, like, typically security vulnerabilities are not the first wave of defects that are fixed in newly introduced software. Typically they address defects where it doesn't function correctly, and then later, when the software reaches when the software well, what do I want to say, like when the software reaches a stable plateau is usually when security vulnerabilities are then hunted down and fixed. And in fact, in a commercial company, if you have a very small team who's very quickly trying to introduce a new service, it actually is, what do I want to say? It's actually not logical to contribute a lot of resource to making the software secure until you can reach the point of a minimum viable product. Because the point of an MVP in business is you try to see whether it's going to be successful. If it doesn't look like it's going to be successful, you stop the work as soon as you can be sure of that, and not waste your resources on something that will be dead. Instead, retool, try something else. So when you're rapidly starting businesses, the more quickly you can determine that you're going to fail, the more successful you can be, because this frees up your opportunity to try something else. So there actually is a time in the product life cycle, early on in its life, when you wouldn't expect security hardening to have been done, because it wouldn't have been the right time in that company's life cycle to invest heavily in security. It would make sense, once they can see that it's going to be viable, to then make sure that it's going to be secure. So the two ends of the spectrum I would be wary of are abandoned code, where you haven't seen it updated in many years, and at the other end of the spectrum, unstable code, because it's changing so quickly. And there's a third resource you could look at as well, which is to try to search for that product's known security vulnerabilities. So if I could think of a very stable, well-known library off the top of my head, there's a logging library for Java called log4j. And this would be a library where you could search Google log4j security vulnerabilities or log4j security fixes, and you would probably find the developer's change log somewhere. And that's a place where you can see is there a lot of activity of fixing vulnerabilities, or is there a lot of activity of discovering vulnerabilities? It's like a length of string. You know, if there's suddenly lots of reports of crimes in a neighborhood, that could mean there's more crimes. It also could mean there's more police catching crimes. So, but high activity is something that you can critically evaluate and ask yourself, does this appear to be safer or less safe than the alternatives?
So,
Thank you very much, Douglas.
yeah, so I'm conscious of time. I wanted to see whether any of our students had any questions since they hopped on.
And for the benefit of the recording, if anyone wants to ask a question, maybe you could briefly introduce yourself as well.
If not, I do have a follow-up quickly. How do you stay current? Because this is a super evolving, I imagine it's incredibly fast developing field. And so what do you need to do to remain current? And also, has there been any incident that completely blew you away in its sophistication?
Since I don't work in the area of responding to security incidents, I might not be able to pick one off the top of my head. But how do I stay current? So it may be surprising that even though software and its capabilities changes quite rapidly, the principles of software security are actually basically some principles that were identified in the 1970s. And it's actually quite seldom that an entirely new attack pattern emerges. So I'll give you an example of this. If we have a website with an input box where I'm expected to type some letters, it might say a website, you know, what is your name? And I would type my name, Douglas. And maybe the programming on the back end of the website will take my name and print a message, hello, Douglas. This is probably, you know, a pattern that you've seen in software many, many times. The pattern here is the string goes in from me, the remote person, and the string is reflected back out. So this seems innocent, but there's a potential implementation flaw here, which is, what if I include characters that are not typically used in a name? What if I include some angle bracket characters and maybe some HTML and then JavaScript commands, so that my name is you know, a couple of normal characters and then a bunch of garbage characters? It might be that when it says hello Douglas, it prints Douglas, but also prints those HTML control characters and actually reformats the page. So what has happened here is there's been a mix-up between data and control. So data, which is my name, or what the computer program expects is my name, and control characters, which would be HTML controls that maybe will reformat the page, maybe justify all of the text to the right instead of to the left. That's a typical thing you could do with JavaScript. Another thing you could do with JavaScript is move all of the elements around, maybe put a window on top of the window that looks like a login page. So here's a case where the software was subverted by mishandling the string, not taking note that these letters, Douglas, were going to be printed out into a context in which certain control characters need to be escaped in order to render properly in their target system. So the target system in this case is the web browser showing the response. But the target system could also be a vulnerable backend component, like something that sends an alert email confirming the transaction. There could be control characters in there that cause extra computer commands to be run. Also, a common target for the data that I type into a form could be a database. And there are also control characters applicable to the database command that the program would use. And these data input validation problems are a very old known pattern. And what changes rapidly is the new places that data input validation basic patterns can show up. And it may be interesting to you that if you study software security, you'll find there are probably 20 or 30 patterns total. And in my career, which is 2020, which is now 13 years in security, I think I've only seen one bona fide new pattern that wasn't known before that was introduced, a new way to get attack data into a program that hadn't been seen before. So, oh, and I do have an idea on your how was I blown away question. So what I will assert is that actually the basic patterns, there's a small number of patterns. You can take a number and let it overflow from the highest to the lowest number. You can have a string that goes longer than the program expected it, and you can start writing data unexpectedly to the memory and do all sorts of tricks that way. You can also send control characters into a string if you know anything about the vulnerable place where that string will later be processed. If a password is handled in a system, you can handle the password inappropriately. You can leave it sitting unencrypted somewhere or leave it in a way that it could be decrypted by the program itself, et cetera, et cetera, et cetera. There's not very many taxonometric categories of the security vulnerabilities. And it really is waves of new developers without specific security education arriving on the job market, and new and complex ways that these same implementation flaws can be slipped into the work in progress. This is what changes rapidly. So to answer your other question, Alan, what is something that really blew me away? I would have to say that it was the new attacks on the computer processors that came out last year or the year before. The idea that you can perform some operations on the computer processor in such a way that you can tease out of its caching and performance enhancing characteristics. You can actually learn information about the other things that CPU was working on and potentially read the data from other programs. That one was really eye-opening to me because I knew that modern computer processors are really complex, but it's not a part of the computer system that I follow personally very closely. And I was really blown away with the assertion that I had never actually seen a working exploit of, what did we call them? I think one of them was not Ghost, but Spectre and the other one. This was a real eye-opener to me because it was completely removed from my area of abstraction in the computer system. I'm always looking at how's the software designed. So you expect this system to integrate with a spell checker over the internet. When you send those keystrokes to the spell checker, is there any private data in there? These are the kind of questions that I quiz the developers on. And if there's private data in there, how are you adequately protecting that data in transit? How are you protecting it from an eavesdropper? If the service is a licensed service, how are you authenticating to that service? Are you authenticating in a way that nobody else can steal your API key and impersonate you and use that service. So there's actually kind of a small number of questions that we ask each time we see a program design that sends data to cross a trust boundary. And seeing the computer processor leaking information about other jobs that it was doing was a real surprise to me.
That's actually really interesting. The one thing that I'm picking up here too is that in this economy that we're heading into, you certainly will always have job security.
I certainly hope so, but just as I would say, 3 months ago, none of us expected, none of us would have really thought that it's very likely a viral infection will put almost every culture in the world focused on the same problem all at once. This might be the first time in human history this has happened. None of us was expecting that.
I think Bill Gates actually predicted this.
Oh, really?
I think in 2015 he's got a speech where he talked about this potential.
Wow. Yeah, I think there were researchers that caused this, that named this this concept disease X. But I was never under the impression that anybody was just waiting for it to happen. I always thought it was such a far-flung impossibility. It was never on my risk radar. But certainly, I could develop myself by reading a lot of things Bill Gates has said. Certainly. So, but I still leave open the possibility that something could happen someday in the world that suddenly makes all computers valueless. There could be something that happens that makes computers useless. Maybe a burst of energy from the sun sufficient to fry every semiconductor, or maybe a new condition that causes semiconductors to not work the way they do today anymore. So,
or a simple loss of power.
So yeah, my risk profile includes keeping open the possibility that someday maybe computers won't be in use anymore, and that I need to keep my cooking skills up to top notch.
So cognizant of time, any last questions, Marianne, or students, Julia? Any of you folks have anything you'd like to ask?
I don't have any other questions, but I really enjoyed listening. Thank you very much.
Oh, thank you very much. I'm happy to hear it. And I hope that I didn't use any terminology that got anybody lost. But certainly, if anybody on second thought has follow-up questions for me, Dr. Jagolinzer has my email address, and I'd be delighted to answer any general questions via email.
Yeah, and I appreciate that. And I do hope to get you out to campus if that's ever a possibility.
I would love to come and visit.
I say that jokingly, but I expect that we'll be opening up again in the foreseeable future, and we'd love to have people out who contributed. I really appreciate your time. Anybody else, students? Anybody? If not, then if you have any closing thoughts, otherwise I'll say thank you.
My closing thought is I'd like to thank everybody for their patience and for asking your very interesting questions today.
All right, well, everybody stay safe. Thank you again, Douglas, for your time, and we'll be in touch.
Thank you very much. And I would look forward to a real physical conference sometime in the future, when the situation permits it.